Hi everyone, my name is Lucas Wei. My project is Explainable Sentiment. It's about text sentiment extraction. Nowadays, 70% people use social media. Companies spend about $32 billion on social media advertising in 2019, and this number would increase in 2020. How this company could know the influence of the money they spend? One popular way is to use sentiment monitor like this. Machine learning models can track the feedback from the customer's social media and create sentiment label. And they always want to know the reason behind these labels, especially for the negative and positive ones. The problem is how machine learning makes these labels like a black hole. So this project is designed to solve this by finding the words that can expand sentiment label. This project can help companies get customer insights to improve their marketing strategy. Let's see a demo first. The model would be loaded in the background when you open the app. This app have two modes. One is you can input single text and a sentiment label. It will get the support word for you. And here is a positive example. And we find the support word is good service, not only good. Another mode, you can upload CSV files. The program will get the support words, and you can download the result to your local machine. Here is the pipeline of the project. I got tweets and did the pre-processing first, and then tokenize it by transformer. After that, I put into two deep learning models. I used LSTM for the baseline because it was the most popular mode to do NLP test before the BERT model came in. And I used the Roberta for the final application. It has a better performance for this project than BERT. Then I trained them on AWS. Finally, I wrapped all the things up to an application using Docker. Here is the dataset I used. There are about 27,000 tweets with labeled sentiment and labeled support words. The sentiment label is almost balanced. This is the training pipeline I used. First, combine sentiment label and the text into the input. Tokenize the text to numbers, and then it went through embedding, and encoders. I use hidden states as output. The final output of the model is the possibility of the start position and end position. Maximum value used to get the support word. One biggest challenge of this project is this. You can see this value of the end position is also high. If this one is chosen by the model, I would only get support word good instead of good service. This is nearly meaningless for a positive sentiment label. I fine-tuned the Roberta model did a really great job to fix this. This is the metric I used to evaluate the model. It's a word level Jakarta score. If you got exactly word, the score would be 1. If you missed the whole word, the score is 0. So the higher the score, the better the result. LSTM got 0.6 and the Robota got 0.7. This fine-tuned Robota did a really good job and kind of fixed the problem I mentioned before. This project can be applied to other scenarios, like product review on Amazon. Now we can know why customer rated it 1 star or 5 stars. Another scenario is chatbot. The robot can get a little bit more empathy. It would have the better conversation with the user. My name is Lucas Wei. My background is electrical engineering. I do like cooking, and I think the process of cooking is very similar to build model. Do the first version and iterate to be better. This concludes my demo. Thank you.